The solar panels on a roof are usually fighting over space they do not have, because a building that needs both electricity and a lot of hot water has to split that roof between two completely separate systems. But one British company thinks you should not have to choose. Naked Energy, founded in 2009, builds a solar collector called VirtuPVT that pulls electricity and heat out of the same vacuum tube at once. It captures around 80% of the sunlight hitting it against the rough 20% you get from a standard panel, and the heat it delivers is hot enough to run a building's hot water. If it works as claimed, it turns the cramped roofs of apartment blocks, hotels, and food sites, the buildings with the least space and the highest heat demand, into something that can finally cover both jobs at once. We are going to take one of these tubes apart, work out how a sealed vacuum lets it outperform a flat panel, and find out whether it really can make standard solar obsolete. To see the scale of what this is aimed at, you have to look past the electricity bill. Heating and cooling still eats up around half of all the energy the world uses, and close to 90% of that demand is still met by burning fossil fuels. Inside buildings, the on-site burning of gas for space heating and hot water is the single biggest source of direct emissions, and natural gas alone accounts for nearly 4/5 of it. So while everyone watches the power grid go green, the heat side has barely moved. That problem lands hardest on the buildings you would least expect. A hotel, a hospital, an apartment block, or a food and drink plant runs a huge, constant demand for hot water, but it sits on a roof that was never big enough for it. To go solar, that building has to install electric panels for power and a separate set of thermal collectors for heat, and there is rarely room for both. It gets worse, because a standard silicon panel is wasteful with the space it does take. It converts only about 15 to 22% of the sunlight landing on it into electricity, and the other 80% becomes heat. That heat is not harmless, because a hot cell is a less efficient cell. On a sunny day, a rooftop panel can climb past 300 degrees Fahrenheit and shed a chunk of its output just when you want it most. On top of that, the spacing, the tilt frames, and the wind loading mean a conventional array only ever uses about half the roof it sits on. So you have buildings with the highest heat demand, the least space, and a technology that wastes most of what it collects. That gap is the problem Naked Energy set out to close. The company was founded near Crawley in the UK in 2009 by Christoph Williams and Nicholas Simmons, who built it specifically to tackle the heat problem that the rest of the solar world was ignoring. They filed their patents for a hybrid collector in 2012, won them in 2018, and refined the design through pilot sites in Malta and across Europe before going commercial. What they ended up with looks nothing like a flat panel. The VirtuPVT is a row of horizontal glass tubes, each one a sealed borosilicate cylinder, 7 inches across, and the clever part is what Naked Energy pumped out of them. Each tube is evacuated, so the air inside is gone and a vacuum takes its place. The same trick a thermos flask uses to keep coffee hot. Inside that vacuum sits a string of full-sized monocrystalline solar cells bonded onto an aluminum plate. They are the same 22% efficient type you would find on a good rooftop panel. Running through that plate are copper channels carrying a water and glycol mixture, and this is where both jobs happen at once. The cells make electricity from the light, and the fluid pulls the waste heat straight off the back of them. That single move solves two problems in one sweep. Pulling the heat away keeps the cells cooler, which keeps them efficient. Meanwhile, the warmth it captures is fed into the building's hot water and heating loops at temperatures up to around 170 degrees Fahrenheit. The light makes power, the heat that would have crippled an ordinary panel becomes useful energy, and almost nothing is thrown away. The numbers behind that are the whole pitch. A standard panel turns roughly 20% of the sun into something useful. The VirtuPVT puts about 20% into electricity and another 60% into heat, for total solar use of around 80%. And because the tubes lie low and flat against the roof, with no spacing gaps or wind-tilted frames, they can cover more than 85% of the available area, against the 50% a conventional array manages. Set against a standard solar panel, the trade-off is plain. Cheap silicon PV is hard to beat on pure upfront cost because it rolls off automated production lines by the gigawatt at 20 to 30 cents a watt. The VirtuPVT, with its precision-assembled vacuum tubes, costs a lot more to put up. Naked Energy does not pretend otherwise, and on a building with low heat demand, the plain panel wins. But that comparison flips on the buildings this is actually for. Once a roof has to deliver serious heat as well as power, the standard answer is two systems competing for one space, and neither getting enough of it. Naked Energy's claim is that doing both jobs from a single footprint delivers at least 50% better net financial savings and up to 3 times the carbon savings per square meter than standard PV on those high-demand buildings. The vacuum does more than save space, though, because it is also what lets these tubes work where a normal collector struggles. By killing the air gap, it cuts the heat lost to the cold outside air to almost nothing. So the system keeps delivering useful warmth on a grey winter day when an uninsulated panel would simply bleed its heat away. That same sealed envelope shields the cells from humidity, salt air, and physical stress, the things that slowly corrode and delaminate an exposed panel over the years. There is also a quieter safety win. A standard commercial PV array runs at dangerous voltages of 600 to 1000 volts of direct current, with all the arc flash risk that brings. The VirtuPVT strings its tubes to stay under 50 volts, which is far safer to install and sign off, though it still has to be wired correctly to keep it there. What is forcing this now is regulation finally catching up with the heat problem. Heating decarbonization has been the slow lane of the energy transition for decades, and governments have run out of patience. The European Union's renewable energy rules now require member states to raise the share of clean energy in heating and cooling by 1.3 percentage points every year, a target that is almost impossible to hit while heat stays tied to gas. At the same time, the obvious alternative is straining the grid it depends on. Pushing every building onto electric heat pumps drives up peak electrical demand, and that often means expensive grid connection upgrades the local network cannot easily absorb. A system that makes heat right where it is used sidesteps that entirely, bypassing the grid and its transmission losses. That is exactly why a low-voltage, roof-mounted collector looks attractive to a utility staring down congestion. For all that promise, this technology has real ground to cover, and the first obstacle is the same vacuum that makes it work. If the pump stops during a power cut or when the storage tank is already full, the fluid stops moving but the sun keeps heating the sealed tube. Trapped inside that insulating vacuum, temperatures can climb to around 464 degrees Fahrenheit. Standard cell components start failing above 248 degrees Fahrenheit, which means delamination and permanent damage. Solving it at scale means building in fail-safe heat dump circuits or venting that reject the excess before it cooks the hardware, plus strict restart rules so cold fluid is never dumped into a baking hot tube. The bigger barrier is cost, and it traces straight back to how the tubes are made. Holding a long-term vacuum seal between glass and metal, bonding the cells precisely, and threading the copper channels all demand clean room assembly, which is slow and expensive next to a mass-produced flat panel. Bringing the price down means scaling production and automating that assembly, which takes patient capital and a lot more volume than the company has today. And there is history here worth respecting, because hybrid solar has failed before. Early flat plate designs delaminated, lost thermal contact, and used polymer parts that crumbled under UV. Because the certification world treated solar power and solar heat as two separate categories, these hybrids fell through the cracks with no clear standard to prove themselves against. What would settle it is independent proof, and Naked Energy has gone after exactly that. In November 2024, it became the first evacuated hybrid collector to earn TÜV Rheinland certification. The testing verified it could survive everything from extreme wind and hail to a temperature range from -40 degrees Fahrenheit up to 464 degrees Fahrenheit. The deployments are already real, and they are not small. In October 2024, the British Library commissioned what became the UK's largest solar heat project, fitting 950 VirtuPVT collectors across more than 7,664 square feet of roof on a Grade 1 listed building. It is expected to cut the library's emissions by 55 tons a year. On top of heating the building, it helps hold the precise temperature and humidity that protect a national collection. Behind that sits the money and the manufacturing to grow. Naked Energy raised the first £17 million of a Series B round in July 2024, led by the energy giant E.ON's infrastructure arm, with the round targeting £30 million in total. That partnership opens the door to E.ON's commercial customers across 16 European countries, while a separate deal with ELM Solar is standing up a factory in Texas to build the tubes inside the US and clear the import tariffs. If you are watching this hoping to put it on your house, here is the honest part. This is not a single home product. It is sold as commercial arrays of tubes aimed squarely at the apartment blocks, hotels, and industrial sites with the heat demand to justify it. The path to your roof, if it comes, runs through that commercial scale-up, driving the price down first. What Naked Energy is really chasing is a different idea of what a roof is for. One surface doing the work of two, on exactly the buildings where space is tightest and heat matters most. The upfront cost is still high and the manufacturing still has to scale, but the tightening heat rules, the strain on the grid, and the institutional money now lining up behind it all point the same way. I hope you enjoyed this video. If you want to stay ahead of where home energy is going, subscribe and stick around.